Hello, my name is Dana Cavanon, and today we're going to talk about feedback loops, specifically mostly negative feedback loops in the non-gravid female reproductive system. Non-gravid just means that the female does not get pregnant. So a little review about negative feedback loops. Negative feedback loops are self-regulating. They pretty much are keeping substance levels within homeostatic levels. In this case, we're talking about hormones. So one organ secretes a hormone, which then stimulates the secretion of another hormone. And when that second hormone reaches levels that are too high, it actually shuts off the secretion of the first hormone. So that's the negative feedback loop. If it was a positive feedback loop, the production of the secretion of the second hormone would increase secretion of the first hormone. This is not really seen too much in the human body, but it is seen in the female reproductive system. The biggest example is during childbirth, but another example that I have listed here is estrogen. If estrogen reaches a certain level, it actually switches from a negative to a positive feedback loop and goes back and starts stimulating the secretion of gonadotropin releasing hormone. We'll get a little more into that in just a minute. So today we're going to talk a lot about the ovarian cycle. Female humans produce gametes in monthly cycles that are on average roughly 28 days. Those are our menstruation cycles. And menstruation cycles can either be described by changes that occur in the ovaries or changes that occur in the endometrial lining. And those two are either the ovarian cycle or the uterine cycle. And we're going to focus on the ovarian cycle and the hormones that influence that today. So the ovarian cycle is divided into three phases: the follicular phase, the ovulation, and then the luteal phase. The luteal phase can also be known as the post-ovulatory phase. The follicular phase is the period of follicular growth in the ovary. It's the most variable phase in length, ranging from anywhere from 10 to 21 days. The ovulation phase is just when the ovary releases the oocyte, and this cannot happen until the follicular phase is completed and the follicle has ripened. And then, again, the luteal phase, like I said, can be known as the post-ovulatory phase. All of these phases are under endocrine or hormonal control, starting with the follicular phase. Estrogen is the dominant steroid hormone in that phase, but it all starts with gonadotropin releasing hormone that is secreted from the anterior pituitary, and that in turn stimulates secretion of follicle stimulating hormone and luteinizing hormone. Follicle stimulating hormone stimulates a group of tertiary follicles in the ovaries to start to begin to mature. As those tertiary follicles grow, their granulose cells secrete an anti-Müllerian hormone. This anti-Müllerian hormone in turn decreases the follicle sensitivity to follicle stimulating hormone, and this is our first example of a negative feedback loop in this system. The anti-Müllerian hormone decreasing sensitivity to the follicular stimulating hormone is just to make sure that no more follicles are stimulating to start developing. As the follicle continues to grow, thecal cells synthesize androgens, which then go back and stimulate the granulose cells to produce estrogen. So as I said before, estrogen is really important in these phases. Estrogen then exerts a second negative feedback loop onto the pituitary, which decreases the follicle stimulating hormone and luteinizing hormone secretion. Estrogen will then stimulate the granulose cells to produce more estrogen, and this needs to occur just because with the decreases in the follicle stimulating hormone and luteinizing hormone, estrogen still needs to be produced. And then as this follicular phase nears the end, ovarian estrogen secretion peaks, and the granulosa cells begin to secrete inhibin and progesterone in addition to the estrogen. This is the point where the estrogen changes to a positive feedback loop, and then it positively feedbacks onto gonadotropin releasing hormone. This leads to a surge in luteinizing hormone and a small surge in follicle-stimulating hormone. The smaller surge in follicle-stimulating hormone is due to the fact that inhibin is being released, and that will suppress follicle-stimulating hormone. So when the estrogen levels reach high enough, it changes to a positive feedback loop on gonadotropin-releasing hormone instead of the negative feedback loop, and this leads to a large surge in luteinizing hormone, and then this is when the oocyte is released and ovulation occurs. After ovulation, the thecal and granulosa cells will combine to form the luteal cells of the corpus luteum. The corpus luteum produces steadily increasing amounts of progesterone, estrogen, and inhibin. The combination of both estrogen and progesterone exerts a negative feedback loop back onto the hypothalamus, so reducing gonadotropin-releasing levels, which and also on the anterior pituitary, which is decreasing secretion of the follicle-stimulating hormone and luteinizing hormone. And then with the addition of the corpus luteum secreting inhibin, this further shuts down the gonadotropin-releasing hormone in a negative feedback loop. So gonadotropin-releasing hormone in the luteal phase is very, very, very low. The corpus luteum has an intrinsic lifespan of about 12 days, so if pregnancy does not occur, these luteal cells degenerate. This then causes progesterone and estrogen production levels to decrease in the ovaries. This in turn then shuts off this negative feedback loop, and then gonadotropin-releasing hormone starts to be secreted more, which will then increase secretions of follicle-stimulating hormone and luteinizing hormone. And this brings us back to the beginning of the ovarian cycle in the follicular phase. This slide is just pretty much a review of everything I just went over with pictures and arrows of each of the organs that are secreting hormones, and as well as the names of hormones and what they are either stimulating the release of, or what they are producing the negative feedback loop to start inhibiting that secretion. This is, again, just a secondary slide focusing on just the hormones that are produced and describing which hormone does what. So gonadotropin-releasing hormone really only stimulates the anterior pituitary to release follicle-stimulating hormone and luteinizing hormone. Those both also just stimulate the release of other hormones or stimulate the cells. But then when we get to estrogen is both a positive and a negative feedback loop. So most of the time it negatively feeds back on the hypothalamus and the anterior pituitary to decrease secretion of gonadotropin-releasing hormone and follicle-stimulating hormone and luteinizing hormone. But again, once the estrogen levels reach high enough, it actually turns into the positive feedback loop back to the gonadotropin-releasing hormone, which then goes to luteinizing hormone to produce the ovulation. Progesterone itself is also mostly negative. There is a short time where it could potentially be positive. And that is when inhibin is also only a negative feedback loop, and inhibin's production only stimulates the inhibition of gonadotropin-releasing hormone and follicle-stimulating hormone.